Hello everyone, I welcome you for yet another video of CSAT. Okay, so in today's video we are going to discuss about time and work. Now when I talk about time and work, this is one of the important chapter not only in CSAT, in other competitive exam where aptitude is involved. And in UPSC every year you can expect 1 to 2 questions from here, right? So you know the questions are pretty simple, and sometimes it feels like the questions are it takes more time due to its calculation. So we have to have an approach where we should not follow the bookish traditional method, which will make you the calculation much larger. So first we'll understand what are time and work, what are the concept involved here, right? And what is the traditional method that we use, and how we should not use the traditional method and we should use the regular LCM approach, and the assuming the total quantity of work and how we are supposed to solve, and how that can reduce your job, how it can give you a power of visualization and help in solving the problem, right? So now, all right, so let's begin. So in the concept of time and work, something called your efficiency, and second, the time taken to finish a certain job. Now, when I say that, when I can compare two people, let's say I cannot compare two people if they are doing a different job in the first place. That means that, let's say someone is constructing a house, another is painting a house. Now I cannot compare between them because they are doing entirely two different jobs. One. Now, whenever you are comparing, the job that both are doing should remain same, right? And let's say somebody is basically constructing one floor, another person is constructing two floor. At certain point of time, if they want to compare both of them, then make sure that they both have same amount of work, then you can compare between them. That is the second thing. Now, what is efficiency, and the time taken? So if I say that if somebody is taking 10 days to finish a certain job, another person is taking 20 days to finish a job. Now who is more efficient? Efficient means who can finish the job earlier. The same work, if you are given to somebody, if he can finish them early, then he will be more efficient. So that means that the person who is finishing the 10 job in 10 days is double efficient compared to a person who is taking 20 days. This concept you have to understand very well, right? So in that sense, that if you are taking more time, then your efficiency is less. You just imagine that you are taking for the same problem, if you are taking 10 minutes to solve it, another person is there who is taking and solving within 1 minute. Who is more efficient? Just because you have taken more time, you are not efficient here. So whoever has taken less time for the same problem, he will become more efficient, right? So in that way, whoever is taking more efficiency, more time, he will be less efficient. So that means that efficiency as well as the time taken to do a certain job are inversely proportional to each other. More time, less efficient. Less time, more efficient. All right. So that is one thing that you are supposed to understand. Now, in a regular textbook, we'll understand how they have solved it and what you are supposed to do, right? Yes. There you go. Abby, you have to understand this, right? So let's understand one by one, right? Let's say there is a certain job. Somebody, let's say A, is taking 10 days, right? Now there is a person B who takes 5 days to finish the same job. Okay, not now. If they start working together, how many days they will take to finish the entire job? This is the question, basic question. Now, how you are supposed to visualize it? Let's say somebody is taking 10 days, right? So 10 days means basically, if I want to divide this, right? So I have equally divided his work for 10 days. One day he will do this job, second day, third day, fourth day, like that. Every day is, he's doing certain part of job. In 10 days, he's actually finishing the job. This person is taking 5 days. 1, 2, 3, 4, 5. Right? First, second, third, fourth, fifth. Right? So if somebody is taking 10 days, then how much job he will do per day? Because when we can compare per day, about that is efficiency is what is the per day work that someone will do. Let's say the A will take or A will finish 1/10th of the work. Right? So that means that if I make complete work as 1, each day he will finish 1/10th, 1/10th, 1/10th. So that is the one work has been divided into 10 part. Each day he will finishing 1/10th of the work. Similarly, if somebody is taking entire job as 1, and if he is taking 5 days, each day one part of the 5, right? So out of 5 part, he is finishing 1 part. Out of 10 part, he is finishing 1 part. So if I say total job 10 days means equal 10 parts he can do. Each day 1/10, 1/10. Now since they work together, first person will finish 1/10 of the work. Second person will finish 1/5 of the work. Now that means that if I see, and if I want to calculate how much they have finished, since they are fraction, and if I want to add that fraction, I will take the LCM of the denominator. In this case, LCM of 5 and 10 is 10. Right? 10 ones are 10. 5 twos are 10. So numerator also has to be multiplied by 2. Right? So that means that 3/10 of the work will be done per day. So that means that, one day 3/10. So that means that if I want to make 10 part of the job, 3 part will be finished in one day. Next day again 3 part, next day again 3 part, right? So that means that the total number of days is nothing but 10/3. That is basically 3.31/3 or 3.33 days. So this is the total number of work or total number of days that both of them will take together to finish the job. This is one way to look into it. Now let's say if there is a C also. Okay. Now let's say there is a C also. He will take, another problem, A, B, C. He will take 4 days. He will take 2 days. Now let's say he is taking 5 days. Now they are working together. So what will happen if A is taking 5 days, 4 days? That means that each day he will take 1, 2, 3, 4. Total, if I say total work as 4 part, for each day he will do 1/4. Similarly, this is A. If B is taking 2 days, that is within 2 days if you are finishing, each day you are finishing half of the job, that is 1/2. Similarly, C will take 5 days, that means that each day, 5 days, 5 days each part, so that will be 1/5 of the work. Right, so if I want to add them, right, if they are working together, then 1/4 plus 1/2 plus 1/5. Then LCM will be, let's say, 20. 4 5s are 2, 10s are 5 4s. So that is 15 plus 19/20. So this is the amount of work they do. So that means the number of days they will take is reverse of it, 20/19. All right. So, this is one way to look into this problem. Now, where is the problem that becomes complicated? Let's say, we'll have another simple problem. Okay. Let's say one is taking 4 days. B is taking 5 days. Okay. That means that, now the job will be asking with certain condition. They are not working together. Let's say A is working on one day, B is working on one day. Next again, alternatively, again A is working, B is working. So that means that, first day 1/4 of the job will be done. Second day 1/5 of the job will be done. Again, third day 1/4 of the job will be done. Like that, if they are, alternatively working, how many days they will take? That is one kind of question. Second is, let's say they start together for first 2 days. Then either A or B leaves the job. The remaining part will be completed by whoever is the remaining person, he will complete. Then how many days it will take? That is another day. Another type of question. In another type of question, initially one person will be starting. Over a period of time, second person joins and they finish the remaining job in certain number of days. Then in what day basically the another person has joined. This kind of problem. Now, as here the day job will be keep changing, because one day one will be doing, next day two will be doing, again somebody will leave the job, then again one will be doing. So these kind of complicated job, that kind of question, if you are doing through fractions, it will take lot of your energy and time. So we will not use this method of 1/4, 1/5 and those things. Rather, what we will do, one, understand now. Now we will assume that, let's say A is taking 5 days, B is taking 4 days. Now, if I want to divide total work, because each day he will do anything divided by 5, he will do work divided by 4. So if it has to be divisible by 5 also, 4 also, then I will assume the work as LCM of 5 and 4. Now what will happen? I assume that there is a 20 units of work is there. Right? That is LCM of 4 also, LCM of 5 also. I mean LCM of 4 and 5. So that is multiple of 4 also, multiple of 5 also. So now you assume that there is a 20 units of work. Now you think that, let's say when A is doing, he is taking 5 days to finish 20 units. That means that per day he will finish 4 units. Per day's efficiency is 4 units. Similarly, since B is taking 4 days to finish 20 units, per day he will take 5 units. That means that if they work together, for example, they will finish 9 units of work. So how much unit is there? 20 unit is there. So that means that one day they will take 9. Second day also they will work. They will finish another 9 units. Right. So now third day only 2 units is there. So they will take 2 by 9 days, because per day they can finish 9. So that means that how many days to finish 2 units? That will be 2 by 9. So the answer will be 2 by 9. Alright. So all we are doing is taking the LCM of the time, so that the efficiency can be divided into a natural number or an integer. Right. So a positive integer. So that the work efficiency can be coming in a proper, so that can be then easily visualize and calculate. That is our basic idea. Now I'll start doing few problems. You'll understand how it works. Okay, a different type of problem I will solve, and I will give you 3 questions for you to solve, and I expect you to put the answer in the comment section. More you participate, more I come up with the videos and making the things easier. Right? All right. Next, let's go one by one. What is the first question? Now I will not, so for first problem I will solve both the bookish method as well as the LCM, assuming a total work as the LCM of the number of days method. Both we will do, right? But for the second, third problem, or fourth problem, whatever how many numbers of the problem that we are doing, for that I will only use the LCM method. Okay, so you can do both method at home and see which is taking what kind of time for you, right? All right. Now A completes a work in 10 days, right? While B and C complete it in 12 and 15 days. Okay, all right. In how many days A, B, C together complete the work? Simple problem. So that means that if A is taking 12 days, total work is there, is equally doing every day equal work. Like that he is doing, let's say 12 days. That means that each day, one part of the 12 he will finish. So that means that if this is time taken 12, B will, 10 days, A will take 10 days, B will take 12 days, C will take 15 days. Now efficiency, that is per day, efficiency is per day, what is the work? Per day he will finish 1/10 of the work. If total work, if I divide into 10 days, each day one part of that 10, that is 10 days. Total work as divided into 12 days, each day 1/12 of the work. Similarly, if he is taking 15 days, that means that entire work if he is dividing equally into 15 days, each day he is finishing in 1 by 15 days. Now if they are working together, that means that he will finish his part of 1/10 of the job, he will finish 1/12 of the job, he will finish 1 by 15 of the job, right? So when he is finishing 1 by 10, 1 by 15, right? 1 by 10 plus 1 by 12 plus 1 by 15. Now what is the LCM of 10, 12 and 15? So it is always easy to do first with the 2 number and then compare with the 3 number, right? So I'll take easy numbers, that is 10 and 15 first. Any number you can take, whatever that you are feeling fine. So I'll take the common 5. So this will be 2, this will be 3, right? So now I know that 2 and 3 are co-prime. So LCM will be product of the co-prime. That means that 6 into 5 was common anyway. So 5 into 6, 30 is a LCM of 10 and 15. Now with this LCM, I will take another number, that is remaining number, that is 12. So 30 and 12. So again, if I say 6 5s are 6 2s are, take 6 out. This will be 5, this will be 2. Now 5 and 2, you know that they are co-prime. So that means that their LCM is nothing but 5 into 2, 10. 6 was common. So 60 is the LCM. Finally, the 60 is LCM. Now if 60 is LCM, alright, if 60 is LCM, that means that 1 by 10 plus 1 by 12 plus 1 by 15 is nothing but it is 60. Now 10 6 are 60. Similarly, numerator also has to be multiplied with 6. So this will be 6. Similarly, 12 5s are 60. That means that if you have changed the numerator from 12 to 60, to keep the ratio equal, what we have to do? We have to also change the numerator that many times. So it has been 5 times. So numerator also, you multiply the numerator also with the 5. 1 into 5, 5. Similarly, this is 15 4s are 60. Similarly, multiply your numerator also by 4. So that is this. So 6 plus 5, that is 11. 11 plus 4, 15. 15 by 60, okay, is the work done per day. So that means that if I cancel it, 1/4. That is, if there are 4 part of the work, 1/4 is happening on this day, right? One day it is finishing, you are taking this part. That means the total work is nothing but, our total time taken is nothing but inverse of the efficiency, that is 4 by 1. Total work or total time taken will be 4 days. So answer will be 4 days. This is your traditional method. Now what is the second method? Second method is just visualizing it. That is, if this is time taken A, B, C, and this is efficiency 10, 12, 15. So now you know that how will you take efficiency. First you will assume the total work as LCM of the time taken, so that all per day work can come in a complete number. So 10, 12, 15, you already know that 60 is the total work. Now I will assume that there is a 60 units of work. That means that, let's say 60 pages you have to study. Like that, 60 units of work is there. So that means that if he is taking 10 days to finish 60 units, per day how much he will finish? 6 units. Similarly, someone is taking 12 days to finish 60 units, each day 5 units. Similarly, if somebody is taking 15 days, that means that each day is only finishing 4. You just imagine that you are taking 60 pages. If you want to finish a 60-page book, somebody is taking 10 days. Per day, how many pages he is studying? 10 pages. Another person is taking 12 days. That means that he is studying only 5 pages. More time you take, less number of pages you study per day. If somebody is taking 15 days, per day is taking only 4 pages, right? So that means that 6 plus 5 plus 4, 15 units. That is, together you are finishing 15 pages. Like that, 15 units of work is done by 3 of them together. One day 15. So there is 60 pages you have to study. If you are studying 15 per day, to finish 60 pages, how many days you will take? 4 days. Similarly, if there is 60 units of work is there, if he is taking 15 units, how many days they will take? 15 for the 60. So 4 days they will take to finish the job. Here you are not adding or doing your the fraction addition, right? That is the first job. Now from this job, now another thing what you have to understand is, here we are also covering the chapter of pipes and cisterns, right? Here in the time and work, what will do? A will do the job, B will do the men will do the job. In pipes and system, pipe will fill the tank. So that means that pipe is doing the job, right? It will take 8 hours to fill a job. It will 10 days, that means that whatever the tank size, that is the total unit of work. And this pipe per minute, how many minutes it will take, that is the total time taken. The efficiency is per hour or per minute, how much it can fill, that is its efficiency. So pipes and cistern as well as time and work, both are same in that sense, right? However, there is a concept of negative work. That is basically, if you are constructing something, then basically you are adding the job, that is positive work. If you are demolishing something, then you are actually negative work. So that means that in a pipe, let's say a pipe is filling a tank, that is a positive work. If there is a leakage, seepage, or another tank is emptying a tank, that is a negative work. So the same amount of work is same, but you show it in the negative symbol, because whatever the work has been done by one pipe, it is reducing by another pipe, so you have to show it in a negative symbol. All right, now we will solve the problem. Two pipes A and B can independently fill a tank in 20 and 30 minutes respectively. Now what I am going to do, I am not going to do with your 1 by 20 and 1 by 30, I am directly doing the LCM method. What I will do, time taken, pipe A is there, pipe B is there. It is taking 20 minutes, it is taking 30 minutes. Only thing is sometimes one is given in hour, one is given in minutes. Then you have to convert all of them into a same unit. This you have to keep in mind, right? Okay, so and second is, if the work is different, one is filling 20 liter ka tank, another is filling 40 liter ka tank, then you have to make sure that the tank size remains same in both the cases. That means that let's say A is taking 20 minutes to fill, let's say 40 liter tank. If B is taking 30 minutes to fill, let's say 60 liter tank, right? Or let's say, a 90 liter tank. Now what are, B is taking 30 minutes to fill, let's say 80 liter ka tank. Now what you are supposed to do? You understand that more time is there, but the tank size is also more. So what I will do? I will think that if it is 80 liter, it is taking 30 minutes. Now I will make this also, this 40 liter also 80 liter. That means that, if it was taking 20 minutes to fill 40 liter, if it was 80 liter, then it will also take double the time. So 40 minutes for 80 liter. This is 30 minutes for 80 liter. Now what I have done, in both the cases, tank size I have made it equal. That is 80 liter, and then I will compare them. So don't compare them for the different units of work. Make that total unit of work in both the cases are same, then you can compare them. Alright. So that is another thing that you have to remember. Alright. So now if that kind of question comes, we will see, but otherwise fine. Right now, if it is a time taken is 20 minutes and 30 minutes. Second, that means that efficiency, that is per minute, is efficiency. If it is taking 20 minutes, right, and this is efficiency. So now what I will do, I will assume the total work as LCM of the time taken, that is 20 and 30. So how do you calculate 20 and 30? Common, I will take 10 out. So this will be 2, this will be 3. So 2 and 3 are co-prime. So the LCM will be 2 into 3, 6 into 10, that is common. 60 will be the LCM. So if total work is 60, that means that if A take 20 minutes to fill 60 liter ka tank, that means that in each minute, how many liters it is filling? That is efficiency, 3. Similarly, if it is taking 30 minutes, per each minute, it will fill 2 units of tank. So total, if they work together, they are finishing how much? 5 units of the tank is filled. Now tank size is how much? 60 unit. Each minute, 5 minutes, 5 units. That means that 60 unit will be 60 by 5, that will be 12 minutes it will take. Alright? Alright. Next. W can do 25% of the work in 30 days. X can do 1/4 of the work in 10 days. Y can do 40% of the work in 40 days. Z can do 1/3 of the work in 13 days. Who will complete the work first? Now what I have to do? Here the job itself is different. Now I have to make 100% of the work in all the cases, so that I can compare them easily. So now that because here 25% is there, here 1/4, that is also 25%, here 40%, it is 33.33% or 1/3. So basically I am having a different amount of work, so I cannot directly compare and sell all them just by looking at the number of days. What I have to do, I have to make the work equal. So that means that how I do it, if it is 25%, what is 100%? That is 4 times of 25%. 30 days it will take for 25%. Then for 100%, it will take, 4 into, as the work has become 4 times more, number of days also become 4 times more. So that is 120 days. W will take 120 days. Now X is taking 1/4. 1/4 is again 25%. So he is taking 10 days. So that means that to 100%, that is 4 by 4, he will take 40 days. Similarly, Y. Y is taking 40% in 40 days. So that means that 100% in 100 days, right? You will take 100 days. Now Z is 1/3 of the work, right? So in 13 days. Next 1/3 again 13 days. Next 1/3 again 13 days. That is 3/3 is the full work. So 3 by 3 it will take basically 39 days. So now who will complete the work first? Who is more efficient? Who takes the less time? That is the question. Who will take less time? 39 days, that is Z. So Z will be the finish the work first. Next. A, B, C working independently can do a piece of work in 8, 16 and 12 days. A alone works on Monday, B alone works on Tuesday, C alone works on Wednesday. Again, A again alone works on Thursday, so on. That means that B will work on Friday, C will work on Saturday, right? Again, A will work on Sunday, so on. It is going on. Now consider the following. The work will be finished on Thursday. The work will be finished in 10 days. Let's see one by one, right? Here you are not working together. Each is working separately on a different days. Now what is your first job? A is there, B is there, C is there. Time taken is 8, 16 and 12. So total work, what is the total work that you have assumed, right? That is nothing but LCM of 8, 16, 12. So 8, 16 and 12, right? Now anyways, 8 and 16, 16 is already multiple of 8. So that means that between 8 and 16, 16 is the LCM. So now we have to compare 16 and 12. 4, if I take out 4 4s are, 4 3s are. Now 4 and 3 are co-prime. So their LCM is basically 12 into common was 4. So 48. So 48 is basically LCM of this. So that means the total work I will assume is what? 48 units. Total work is equal to 48 units. If total work is 48 units, then if he is taking 8 days, per day how much he will do? Per day 48 units, he is taking 8 days, per day he will finish 6 units. Similarly, he is taking 16 days per day, that means that he will finish only 3 units. So the 16 days, 16 3s are 48. Similarly, 12 days, that means that each day is taking 4 units. That is 12 into 4, right? So that is basically 48 minutes. All right. That is how the things has been done, right? So if I see A is doing 6 units, B is doing 3, E is doing 4. Now what will happen? A starts with Monday, he finished 6. Then on Tuesday again 3 units. Again on Wednesday it will be 4 units. Thursday 6 units. Friday again 3 units, right? Saturday it will be again 4 units. So that is 6 plus 3 9, 9 plus 4 13. 13 again 13. So that is basically 13 plus 13 26. Again on Sunday we will do 6 units. Monday you will have again 3 units. Tuesday again you will have 4 units. That is 26 plus 13. So if you look at it, 39 units is done. Now again if they all three work, that is 52 units will happen. But that much work is not there. Only 42 units is there. Now once you understand that is 13, you have to multiply 13 till that number where it should not cross basically the total amount of work. That is, if the total, initially if they work on alternative days, 13 unit is then, 13 4s is 52, so you don't need to multiply with 4, you multiply with 3. 13 3s are 39. That is 3 days ka, 9 days if they work, basically, that will be 39 unit job is done. Now 9 unit is there. Who will start on the 10th day? 10th day A will start. He will finish 6 units of job. So that is 39 to 48, 9 units was there. A has finished 6 units. That means that out of 9, if 6 is finished, remaining 3 units of work is there. Now B will come. He will finish 3 units of the work per day. So that means that remaining 3 will complete on that day. So that means that 9 plus 2, 11 days they will completely finish the job, not in 10 days. Okay. So that means that second statement is wrong. Now the first statement, if it is 11 days, so they are starting the work from Monday. So 1 week, that is Monday to 1 Sunday, that will be 1 week. Again Monday will be 8th day, right? 8th, Tuesday will be 9th, Wednesday will be 10th, Thursday will be 11th day. So the work will be finished on Thursday. This is correct. So in the calendar also, if you know, total number of work is 11 days. So if I want to divide it, gap is 7 by 11. So that means that remainder will be 4. So just add 4 day to Sunday, right? So that means that if there is total 11 days, let's say he's starting from Monday and he's taking 11 days. The gap between these two is 10, right? When you divide 10 by 7, remainder will be 3. So add 3 days to Monday. That is Tuesday, Wednesday, Thursday. So the first statement is correct. Second statement is incorrect. All right. Right now, A, B, C alone can finish a job in 20, 25, 30 days. A and B start a job. However, they leave it after 10 days. Remaining part of the job is finished by C alone. How many days did C take to finish the job? Again, visualization. A, B, C. Time taken is 20, 25 and 30. Now efficiency will calculate, that is per day work. To calculate efficiency, we want total work. Total work is nothing but LCM of 20, 25, 30 as I told you before. If you want, take any two number randomly. I will take first 20 and 30. That is easy to calculate because 10 is common, 2 is out, 3 is out. So since 2 and 3 are co-prime, their LCM is 6. 10 was already common, so 60. Now 20 and 30 will give you 60 as LCM. You compare 60 and 25 now. Now with which number it will go? Both will divisible by 5. Right. So if I take 5 out, 5 12s are, 5 5s are. Now 12 and 5 are again co-prime. So that means that LCM will be nothing but product of these two, that is 60 into already common 5 was there. So 60 into 5, 300 units. Assume that total units is 300 units. Now total units of work is 300 if he is taking 20 units to finish 300 units. That means that per day, if you think that you are finishing 300 page book in 20 days, per day how many you will do? 300 by 20, that is basically 15. B will do 25 days, that is 25 by 30. How much it will be? 12 pages. Similarly, C will take 30 days to 300 pages, that means that each day 10. Alright. So that means that now you don't need to add them because the question is saying A and B start work together. C is not in the scene. So if A and B working together, that is 15, he is finishing 15 units, he is finishing 12 units. Together they are finishing 27 units per day. Like that, how many days they are working? 10 days they are working. So 27 into 10, that is 270 units of work is done. What is the total work? 300 units. So that means that when they have left, how many units are left? 30 units are left. So now C is doing the job. 30 units of the job is left. Now see how many units he will finish. 10 units he will finish. If he is finishing 10 units to finish 30 remaining units, how many days he will take? 3 days. Right. So how many days did C take to finish the job? 3 days. That's it. Right. It's more about visualization, no adding of fractions. Otherwise, what will happen? You have to do 1 by 15 per day, or since he is taking 20 days, his per day job is 120, 1 by 25. Then you will add them, then multiply with the 10 so that you will come to know. Then remaining work you subtract from 1, so you will get the remaining work. Then you have to divide it by again 1 by 30. So that much of calculation is not required when you can visualize the problem. So what is the visualization? First take the time, then total work is nothing but LCM of the time taken. Then you make the efficiency of per day by looking into it. Then you, whatever the problem, you start visualizing and doing. Right. Now, this is the last problem we are doing it for today. Right. X and Y can do a piece of work in 45 days and 40 days respectively. Right. That is, first what is our job? X, Y, time taken. One is taking 45 days, another is taking 40 days. They begin to work together. Okay. First they work together. Right. However, after certain days, X leaves the job after n days. At what day we left, we don't know. That they have not given. Then Y completes the remaining work in 23 days. Right? So, in the remaining 23 days, remaining work, whatever that has been left, he took 23 days. Now, the question is, he left after n days. What is that then? That is, when did X leave? After how many days did X leave? Right? Now, again, see, if you are thinking about this problem, we are not worried too much about it. First, we'll always worry about total work. What is total work? Total work is LCM of 45 and 40. So, if it is 45, 40, what is common? 5 is common. I will take 5 out. 5 9s are 5 8s are. So it is co-prime. That means that what is co-prime? There is no common factor between these two numbers. Okay. If it is you are getting, let's say, 12 and 8, then they are not co-prime. You have to take another common, that is 4 common, then you have to make them co-prime. So in this case, basically, we are getting 9 and 8. So 9 and 8 are co-prime. So that means that LCM of two co-primes will be multiple of it, 72. 9 8s are. Into 5 was anyways common. So 72 into 5 will be 7 5 are 350, 360. Right? 7 5 are 350, 2 5s are 10. If you add it, 360. That is what I will do. I will assume that total work is 360 units. Now per day, he is taking 45 units. So that means that 45, 45, 90 like that, So total he will take per day 8 units job he will finish. Right. Similarly, if he is taking 40 days, so that is 40 by 360. So that is he is finishing 9 units of work. Okay. That is okay. Now what is the problem? They have started working together. That means that when they started working together, how many units they will do? 17 units. Now we don't know for how many days they work together till X left n days. So each day 17 into n. 17n amount of job is done. Okay. Now what will happen? He left on some day. Remaining work was done by B or Y in this case, who took 23 days to finish the remaining work. Now you can see Y is finishing actually per day how many units? 9 units. So if he has taken remaining work in 23 units, 23 days, what was the remaining work? Each day 9 unit. He took, this was the job done, that was the remaining work. That is 23 days he took, each day is finishing 9. That means that 23 into 9, 230 minus 23 will be 207. So 207 units of the job was done by Y alone when after X left. That means that if total was 360, that means that 207 was done by Y alone after X left. That means that they worked together and did how much? 153 units. If they have done 153, each day 17 units, to finish 173, how many days they would have taken? 17 by 153, 17 nines are, right, is 153. That is after 9 days, that means that they worked together for 9 days. So after 9 days he has left. So the question is, what is the n equal to? N equal to 9. That's it. Right? So it is a visualization that will help you to understand the problem. Now there are certain problems that you are supposed to do. 20 men are supposed to work to complete a work in 10 days. After working for 5 days, they realize only 1/4 of the work is done. Now, how many more men they need to employ to finish the work on time? Option A, 40. Option B, 30. Option C, 20. Option D, 50. This is the first problem for you to solve. Second, if 20% can clean 20 floors in 20 days, then how many days can 16% clean 16 floors? A very, very good problem. 25 days, 24 days, 10 days, 16 days. And in my class, most of the students that they go wrong is this problem, right? It's common. So please think about it and solve it. That is, if a 20% can clean 20 floors in 20 days, then how many people or how many days? 10, 16% clean 16 floors. 25, 24, 20, 16. All right. Now, 3 taps A, B, C together can fill a tank in 6 hours. Tap C alone can fill a tank in 12 hours. To fill the tank when it is empty, all the 3 taps are started together. After working T hours, tap C is closed and the tank is filled in 8 more hours. What is T equal to? Again, think about them and solve them. 1, 2, 4, 6. I want everybody who are watching or serious about it, has to solve the problem and put the answer in the comment box. I'll be watching for the comment. So more you participate, I'll understand that you are understanding the concept and I can try to simplify. Now in the time and work, there is a second part, that is different men are working, different women are working, that is different efficiencies involved, then how to do it. Or sometimes the work will be 8 men worked for 8 days and each day they are working for 4 hours. That is, number of days are different, number of men are different, number of hours they were working per day is different. So that kind of job and the different efficiency including men, women and children, that we will be doing in the next session. So till then, take care. also participate in the comment section. See you in the next video. Thank you.